So, welcome. My name is Eva Wolfangel, or in English-speaking countries, they say Wolf Angel, which is, of course, much nicer, and I really like it. So I'm a Wolf Angel, and I'm your host today. So we are talking about how AI can help journalists, and I warmly welcome my panelists. We have Varada Korhatka. She is currently a computer linguist at the University of British Columbia in Vancouver, and she researches how online comments can be automatically classified. And I think this is quite important topic for journalists, because I see, and maybe you do observe this as well, that many online news magazines just shut down their comment section because it's too hard to moderate all of these comments, and there's hate speech occurring and fake news and everything. And I know there's a parallel session on audience engagement, and I think this is the totally opposite of audience engagement if you just say, please don't comment, we don't talk to our audience. So maybe there's a solution for this we hear today. Then we have Jonas Kuhn on the left side from your perspective. He's also a computer linguist. He's researching at University of Stuttgart how AI can be used in humanities, and he's doing as well some projects with journalists I will tell about later. And in the middle we have Jeremy Merrill, who worked on investigative projects for Propublica and who is now experimenting with AI for reporting and developing tools for journalists at the Quad AI studio for the common good and sponsored by the Knight Foundation. So welcome to all of you. And I would like to start with a short transparency hint. A few years ago I had a project with Jonas Kuhn, who is sitting here today. And in the end, this project, of course, is the reason why he's sitting here, and this project as well is the reason why I pitched this session, because I really found it interesting and important for journalists to know what we can do with AI. And when I started this project, it was called DebateExplorer. I've been writing a lot about AI until then, but I never tried it out on my own. So this was my first chance to try out what we can do with AI. I had the idea that this technology could advance investigative journalism because I heard from Jonas in a talk that if you want to search large amount of texts, which often is the start of a research, they can find, or AI can find patterns, and it's of course such large amounts that we are not able to read on our own. Back then I had written a lot about privacy and data protection, and all the experts told me that it is one of the fields where lobbyists are overly active and not always in a way that serves democracy. So for example, corruption, of course, is a problem in lobbyism. So I thought it might be useful to use AI to search through protocols of parliamentary debates for patterns and draw our attention to points where politicians change their mind about a topic. And if you look on these protocols, it was really piles, if it were piles, but of course they were digital, of protocols you never would be able to read it on your own, or at least you would need someone who pays you for some years to do this. So Jonas was interested in this idea, and we applied for funding, and we had then 9 months to train a system which in these debates not only recognizes what politicians are talking about, but as well what is their opinion on it, and then find out when this opinion changed. And I think I do not say too much when I say that it was difficult. These debates are full of rhetoric, and it is sometimes difficult even for a person to understand if someone at this moment argues for or against something. Of course, we humans, we know the politicians, and we know the background, and for us it's easier to find this out. But my job was to tell this AI on every single point, is this person now speaking for or against this topic? And it was really hard to decide. But you need to do this, that the machine can find these patterns later on its own. And if you do that for a while, if you train such a system, even as someone who is not into AI, as a journalist, so I'm really not an expert about this, then you know, or you find out what are the chances and what are the challenges around AI. And I'm still convinced that this technology can help us and can really improve journalism. And how exactly this is what we want to discuss today. The plan is that each of these 3 panelists give a very short input talk about their work and some very special projects. I asked them not to give an overview, but more talk about really examples that we can learn from. And afterwards we will discuss it, and finally I will, of course, open the debate for you. So, Verada is going to start. Welcome.
Okay, hello everyone. Oh, I think. Can you hear me? Okay. Yeah, so my name is Verada Kollatkar, and today I'm going to tell you a little bit about our project on automatically identifying constructive comments. And this work is in collaboration with Simon Fraser University in Canada and Google Jigsaw. To begin with, I'm going to show you 2 example comments posted on this video, which was published by New York Times just 2 days ago. And the title of the video is, "Please Stop Telling Me America is Great." And so I want you to read the comment, both comments, and then tell me which comment do you think is more constructive. I'll give you a few seconds to read the comments. Okay, so how many of you think comment 1 is more constructive? Yeah, so this more or less agrees with my judgment, and I guess why we think so is that in comment 1, the person is making some point and also providing some reasons, some personal story, so that kind of makes us feel that, okay, maybe this comment is more constructive. And this is the goal of our project. So what we want to do is we want to build computational methods to identify such constructive comments. And why we want to do that? So first reason is that news articles, they get vast number of comments. So the video article I showed you before, just in one day, it got more than 1,000 comments. And so and then some comments are good quality, some are low quality. And there is this other dark side of the internet. So there have been many articles, many documentaries published. They talk about miserable lives of human moderators and the serious psychological problems they go through. So and then because of the challenges, what happens is that many news outlets, they close down their commenting section, and this is a problem. And so there are many, because of these problems, what we thought was that, okay, if we develop some computational approaches to organize comments, then that might be useful. And so there is this approach by Google, for example, for content moderation, it's called Perspective API. And they have this web interface where you can type your comment, and then it tells you the toxicity level of that comment. So for example, here the comment is, "This candidate should rot in hell." And then the system tells you that, okay, this comment is 94% toxic. Now what we do is we look at the flip side of the problem. So instead of identifying toxic comments, what we focus on is constructive comments. And why we want to do that is, so our hope is that if we are able to identify constructive comments, then we can promote these comments, and we can show them at the top of the commenting section. And our hope is that it will create this positive contagion effect. Okay, so we wanted to solve this problem. We wanted to we wanted to build a computational model to identify constructive comments. So first thing we look at is whether constructiveness is same as non-toxic, right? And so for that, what we did was we had labeled data of around 12,000 comments, and we looked at is there any relationship between toxicity and constructiveness in these 12,000 comments? And here I'm showing you a scatter plot of this data. And what we see here is actually there is no constructiveness and toxicity are orthogonal to each other. What that means is that there can be constructive comments which have some toxicity in them. Okay, so this was the comment we thought was constructive before, and if we put this comment in perspective system, then it told me that, okay, this comment is 37% toxic. But if I just add this last word from the comment, nuts, and then the first sentence, that's stupid, then all of a sudden the toxicity level goes to 84%. Okay, so I mean, it will be a shame if we just filter out this comment because it has some toxicity, it has high level of toxicity in it, because the comment is still constructive, right? So our suggestion is that we should consider constructiveness along with toxicity when we are filtering online comments. And how do we build models for constructiveness? So what we do is we use supervised machine learning techniques. And what that means is that we collect large amount of data, like exemplary positive examples for constructiveness and negative examples for constructiveness. And then these supervised machine learning models, what they do is that from the data, they look for patterns, and then they store these patterns as a model, and then when you have a new comment, the model predicts the class, whether the comment is constructive or not. And for constructiveness, we used New York Times picks. So I don't know, how many of you have seen New York Times picks? Yeah, so New York Times, what they do is that they have like human moderators, a team of like 14 human moderators, and they have been doing this for a long time, and they go through all comments, and they select exemplary comments, and then they have this tab in their commenting section called New York Times Picks. So we think that, okay, maybe this is a proxy for constructive comments. So we take these as positive examples, and then we also label some data for negative examples. And then we feed this data to our machine learning models, and the machine learning models, later they give us predictions for new comments. And with these models, we achieve like around 93% accuracy. And there is this last point I want to make is, so the number 93% looks really good, but you have to be really careful with these models. So for example, when we were looking into, when we were analyzing our models, we saw that in our data, there is this, so it is very much skewed with length. So constructive comments, they tend to be much longer, and non-constructive comments, they tend to be very short. So some of our models, they were very sensitive to length, and then they were not learning any nuances of the language, but what they were learning was this length feature, which can be easily tricked, right? So one thing that you kind of have to do is you have to be careful about what models you are using, and then maybe it's better to choose a model that has maybe a little bit lower accuracy, but it is of much practical use and which is generalizable. Yeah, so and then there is web interface available for our work. You can try it out, and thank you.
Good afternoon, everybody. Thanks for coming out. My name is Jeremy Merrill. I'm a journalist who focuses on using machine learning for reporting at the AI Studio, which is part of Quartz, and I'm based in the United States. I want to talk to you all primarily today about two examples of stories and projects that I've done using AI that will hopefully sound familiar to you all in some of the journalism work that you do, that will hopefully pique your interest and hopefully excite some ideas that you might have where this sort of technique might be something that you'd look into possibly using yourself in your journalism work. The first of those projects is about the United States Congress, and the second one is about tips received about hate crimes or hate incidents. And if we have time, I want to talk a little bit about how these AI tools fit into really familiar investigative journalism workflows. These aren't doing the entirety of an investigative journalism project by any means. They're just one important piece of making sure those projects are successful. So here's something that if you talk to a bunch of American political nerds, that sort of everybody knows, that former Representative Paul Ryan, he used to be the Speaker of the US House, is obsessed with tax policy. This is sort of generally known. And if you asked an expert, they would say, well, everybody knows this. It's sort of obvious. Another thing that everybody kind of knows, 2 weeks ago, one of the things that the US Congress was talking about was this proposed revised trade agreement called the US-Mexico-Canada Agreement. Again, you could ask someone who follows the news about politics in the United States about this, and they would say that they know it. But for both of these claims, there's not really any sort of fundamental single piece of evidence that you could cite for this. Instead, it's just sort of an atmospheric thing that everyone would agree with, but is tougher to sort of find a single piece of proof for it. And so my goal with a project that I did in 2017 at Propublica was to train an AI model that would come up with these sorts of judgments and put them on the internet for people to look at. And it would generate these judgments both for the cases where political nerds sort of already knew the answer, and for lesser known members of Congress for whom people didn't know as much. And since we were using the same methodology, we could trust the results that came out when the model told us something about someone we didn't really know anything about. And so the system that I'll talk about more in a minute generates those sorts of claims. You can go to the Propublica website, to the Represent project, and it'll tell you that Representative Paul Ryan, who's there on the left, talks most about taxation and a little bit about some of these other topics. And Senator Chuck Schumer, who represents New York and New York City, you wouldn't be surprised to learn, the model says, talks a lot about transportation and public works, because the New York City subway is in a lot of trouble, that sort of thing. Similarly, this same project generates a list of topics that the US Congress talks about for each week. The fourth one there is the USMCA. And in addition, that week, a couple weeks ago, they were talking about a bunch of different bills, FARA, PFAS is a chemical, that sort of thing. Again, someone who reads the news would be able to tell you this, but rather than me as a journalist having to call up an expert every week and say, hey, what did Congress talk about? Instead, we can get a computer to do it. The way that we generated both of these two kinds of conclusions was with a system called Word2Vec that uses a lot of math that I don't understand. And what we did is we took all the press releases that all the members of Congress generated in every week, fed them into this system, and it turns these it turns the press releases into this big 100-dimensional vector space that we can use to categorize each press release into those topics that you saw, like emergency management and taxation, just sum up what each member of Congress talks about to get their focuses. And then for what I showed up, this is not going the right direction. What we've got here is a pretty simple mathematical technique that pulls out which words occur most often in all the press releases in a given word, but not so often for the previous handful of years. And that turns out to correlate fairly well with some of the things that you might say are what Congress talked about for a given week. Second project that I want to talk about is on a separate topic. In the United States, there is no nationwide database of hate crimes or hate incidents that are motivated by racial bias or gender bias, those sorts of things. And this became a topic because of a thing that happened in November of 2016 in my country, a sort of surprising election result. And so Propublica, again, built this database. The goal was to collect tips from folks in the United States who either had been the victim of such an incident, had witnessed it, or had just read a news story about it. And the goal was to collect all of these into a database so journalists who are interested in things that were happening in a particular region of the country or a particular kind of bias incident could get a big list of these incidents so they could look for patterns, write stories. The way that Propublica did this was to have an online form that they promoted and other media partners promoted that would ask people, all you had to do to submit a tip was to write out a narrative description in English or Spanish of what had happened. And then optionally, you could check a box for the reasons that the victim of this incident was targeted, was on the basis of their race or their religion or their gender or so forth. But that was optional, because we know that when we ask people to, in these sorts of crowdsourcing projects, the more questions we require, the fewer people actually submit the answers. So that's why this was left optional, so more people would submit things. But it makes it a lot harder for for journalists to use this database if there are a whole lot of incidents that don't have that classification. So we used a very simple AI system called naive Bayes. It's not deep learning, it's just sort of old-fashioned statistical machine learning that finds patterns in the language that's used in each of those categories to sort of fill in the column where people had left it blank. And that was able to make it so that journalists who focused on a particular area or who focused on a particular identity group could use the database to find incidents that were relevant to them, as if everybody had filled in the column. And I don't have a whole lot of time to talk about investigative journalism workflows, but you can imagine how these sorts of projects might fit into an ordinary journalism workflow. You still have to do this sort of ordinary community outreach work to get people to fill in the hate crimes tips database. And after the AI does its job, you still have to write your story. But because the AI is sort of filling in the blanks for you, we can make the database a lot more useful for journalists. That's what I've got.
So good afternoon, my name is Jonas Kuhn, and as Eva mentioned, so I got into this idea of looking at how AI might be helpful for journalism in a project we had together, and I will mention that also. So I will not so much look at Journobots that are kind of living on their own, but more at kind of ways of using AI for research purposes and then still have a journalist write basically the stories. So building adaptable search filters maybe. So the scenario, and Eva already described it a little bit, is, so imagine we have a lot of text material that no one could possibly read, and we want to find relevant pieces there for a certain hypothesis. So there are basically various ways one could go about. One is to use keyword search, obviously, and then you will basically, if you're clever making up your list of keywords, you will probably find stuff, but you may actually miss things that just were expressed with a different vocabulary that you didn't think about. The other option is you can maybe use existing tools, so generic NLP tools like sentiment analysis tools, and there are also classifiers that will find particular content areas maybe in the text if there's some ontology. And there's also unsupervised clustering. But if your hypothesis is not matching these things, actually this is still going to leave you a lot of work to do manually. So the idea, even if you kind of cross-cut these filters, the idea is, hey, with AI and machine learning, isn't there another way to go about and basically train your purpose-specific classifiers? And this is what basically we started playing around with And the idea, this is basically showing how supervised learning works. And imagine we have, our hypothesis has to do with a debate about value-added text. That was actually something where there were lobbyist activities that are known to have had an effect in the German parliamentary debate. So we picked that as an example. So we basically want to have a classifier that labels certain documents that are blue because they're about this topic, and doesn't label others, the red ones here. And the way you can build such a system is to basically do some sampling from the full text and then have someone sit down who knows about the distinction and labels a few data points manually. So these are then the training data. And then you use some algorithm that will induce a predictive model, and then you can basically use the same model to kind of label new data. And if you do that, so this is basically your classifier separates the space somehow. If you then apply this to your development data, you may actually find, oops, there are actually a few coming out on the wrong side. And so you can maybe, if you have the time, you can maybe redo the process in Bootstrap a better one, retrain systems. And this is actually something, if you have an easy enough task, it's actually a quick thing to do, right? And so you can actually have a fairly precise classifier if the problem is of a kind that you can get there. And so we basically, over a number of different project contexts, we came up with this interface that supports annotation in a relatively intuitive way, and Andre Blessing should be credited for doing all this development work. So I'm not going into details here, but we use a pre-processing step that uses unsupervised methods. So there's these latent topic techniques. So you already have a little bit of an idea where to look. And then you have to basically, you get a list of documents that you should look at. And on the right side here, you basically highlight passages of text. And then you basically have to click a box for the correct category that you want to assign to it. And then you go over it and you can press a button to train a model and see how well it does already. I want to give you a bit of a concrete idea in which context this type of approach we played around with. So the first one is the DebateExplorer project that Eva already mentioned, and there are two other projects that I wanted to briefly highlight. So this was funded by the Volkswagen Stiftung, and the target documents that we picked was basically parliamentary debates, and the question that we basically followed is, can we maybe detect lobbyist activities in certain changes of politicians' minds, basically. And if you train a classifier, for example, for the value-added text, we can display the full set of documents along a timeline and maybe along the speaker's party membership. And then you may actually find patterns that you didn't expect. Maybe some party was actually at one point talking about something in an unexpected way. So this is how you can imagine we would use or offer this. At the end of the day, you still have to, of course, do your further research yourself. The second context that I wanted to very briefly mention is collaborations with people from humanities disciplines like literary studies and philosophy. So there we basically use similar techniques in order to extract passages from literary text, for example, medieval novels. And so in this context, basically, it is interesting to extract character networks and answer questions like, can a character network like this possibly inform the interpretation of a literary text or the historical developments? And the third example I wanted to give is actually a collaboration with political scientists in Bremen, funded by the German Research Foundation, and they are interested in discourse networks from a political science point of view. So actors making claims and maybe following other people's claims. And the question behind this is, what can the dynamics that you can observe in actual debates maybe tell us about the way processes work that drive political discourse. And a nice example that these researchers actually labeled by hand was in the debate in Germany after the Fukushima accident. I will highlight here, this is what Merkel claimed a few days after the accident. So her claims was one should do security checks, and the Green Party and SPD, Social Democrats, claimed one should exit from nuclear energy. And then 10 days later, you will actually see that Angela Merkel had basically joined this coalition. So that is, of course, that was a very unusual course of action. So and what these political scientists used to do is actually do hand coding on paper. And in the project that we basically developed from the DebateExplorer, we support this with a lot of machinery from computational linguistics and AI. So the lessons learned, I wanted to conclude with two important lessons that we learned doing this. So if you have enough training data, especially deep learning methods can actually pick up even very subtle distinctions, but it is actually often, so what you would normally expect that you could logically separate between different dimensions of a text, like the content and maybe the speaker's stance, this is not easily achieved. So in a typical example from this is sentiment analysis that makes it clear why basically is, imagine there's water vacation, every night a warm breeze, and then water hotel bar, we mostly got warm beer. So the polarity of warm very much depends on which context it is used in. And when you train these models, they will basically always learn a holistic view of things, so it's not easy to separate things logically. And the downside of this is that you actually have to spend quite some time training your systems if you want to use them on new data. So it's probably not really good for quick research. The other lesson learned, and then I will finish, is basically machine learning classifiers will very reliably yield the same results every instance of applications. This is what Jeremy also pointed out. But as a kind of negative thing to be aware of, the training data may include some implicit biases. And these, the classifier will also pick up. And so this is known, right, cultural biases. But the other thing you also have to be aware of is if you have training data and you apply a classifier trained on these, you actually have to buy in that the application data are exactly from the same sample of data. And this is not typically the case. So and if it's not the case, you cannot be sure what's happening. So at the end of the day, if you want to use machine learning, you actually have to couch it into a process of very reflected application. So you have to validate your machinery on independent data. But I don't think this is a bad outcome because it's actually not fundamentally different from what journalists are used to doing anyway. So you always check your sources. And so this is just another instance where you have to keep a workflow of being very critical with the sources of your information. And so at the end of the day, I think one could even argue that if we promote data literacy and protect ourselves basically against implicit biases, we will maybe not only resolve issues that come from AI, but some kind of implicit issues that were around even before using AI. So that is basically my last point here. And I will switch back to the overview slide now. And pass the microphone to you.
Thank you so much. I think what Jonas just mentioned and Jeremy before as well is that there are some problems coming with the use of AI. Germany, you said it nice, this word-to-vec things are complicated, you don't understand math, and that's what I hear often from journalists, and I think, of course, you don't have to understand at least this complicated math which is behind word-to-vec things. But I saw a nice article from scientists about these word-to-vec things, and it was called "Man is to computer programmer as woman is to homemaker." So these word-to-vec things, they somehow map meanings together. That's how I understood it. And in this title, "Man is to computer programmer as woman is to homemaker," there's, I think, much of what you need to know about this bias problem, because these word-to-vec things and many other machine learning models tend to take prejudices, of course, which are already in society. which leads to my question to the three of you. What do we journalists have to know about how AI works to use AI properly and to not to run into these biases and to even make them bigger? Maybe Jeremy, do you want to answer first?
Sure. That's a great question, Eva. I think that one of the key things for journalists to know, whether we are using AI ourselves to sort of superpower our reporting, or if we're covering AI that's being used in academia or science or government or commerce, is to really think about the slide that Jonas had up, with the documents and the line between them, if you remember that slide. And it was the second version of the slide that had some of the documents on the wrong side of the line. It's important to remember that AI systems, despite the really cool sounding name of artificial intelligence, is really kind of just a fancy name for drawing some lines. And sometimes those lines are right, sometimes they're right really often, but they don't have some sort of special access to the truth. They're just a mathematical way of guessing. And so we shouldn't treat the claims that come out of AI as being definitely correct. It's just a computer guessing mathematically. And that computational guess can be wrong due to randomness, it can be wrong due to chance, it can be wrong due to societal bias. And so as long as we understand that this isn't some sort of special fountain of truth, we'll be in a better place.
Jonas, you want to add, or Verade?
I completely agree. I would just want to add something that I also tell students who are using AI and who will probably know a little more about the math. They also don't know everything.
This doesn't help.
I think one has to be completely aware of all of what Jeremy said. But from then on, you don't have to understand the math of your machinery, but you have to actually look at the data. This is what I always most people tell newcomers to AI, look at the data. So you should actually, before trusting whatever comes out of a magic AI, you should look at a few data instances for which you have an intuition. And then maybe pick some that you know are kind of tricky and then just check what the system is doing, right? And then you will already get an idea where it's kind of making a good prediction and where not. So this is everyone who's using AI should do this, and I think much too few people do this. There are also people who publish papers. You ask them at the conference about the data, and they have no clue. But oh yeah, I picked this data set and I improved the numbers from 92 to 98, so I'm cool. So.
Verade, you want to add something?
Yeah, so I guess one point I want to add is, when we develop models, I think we are not aware of these biases. And so, for example, the example you gave us, that computer programmer is to man and nurse is to woman is to home. Yeah. So I guess that was the case with the initial model of Word2Vec. And then when it was out, then people realized that there is this bias, and then they kind of, the later models of Word2Vec, they kind of incorporated this information, and now if you try these models, this bias is no more there. But I guess initially when we develop models, we don't know what kind of cultural biases there are going to be. So it's always better to be careful about these things.
You made a similar point about comment moderation, and I researched this a little bit for an article a few months ago, and I found the example you mentioned, that these systems thought alone the length of the comment is the main factor where you can see if it's constructive or toxic. I heard from another example where researchers just added the word laugh to comments which were classified as toxic, and they were all of a sudden not toxic anymore just because of one word, and of course people find this out and use this. Another system found that bad grammar and spelling is often associated with hate speech. And of course the problem is if such systems now do comment moderation for us and they classify comments of people who are less educated as toxic, automated, that might be a problem. Is there a chance for us to avoid this, or to avoid these traps, to find out what to do?
So I guess, how I understand it is it's the time. I think initially models will make these kinds of mistakes, but as we know, as we have more data and as we notice more of such errors, then we incorporate this information in our models and then we try to make the models better.
And so we have a chance, we have laymen as well, have a chance to, if you work with AI, to find things like this out, or how could we deal with that? In the end, to me, often it looks like we just have to trust the systems because we can't open them and look inside them.
Right, so these are like nuances of language, right? And then, so for me, I think AI is not there yet, so it picks up on very easy cues. Sometimes, there are some complicated models that can understand nuances of language. But yeah, you can, so there can be mistakes like that for a while at least, I think.
Jeremy, you showed us this example of this, people had to click boxes and, I know I don't have my questions anymore. Wait, I saw this when you answer. And there is a problem with training data, I think, if you have rare examples, so AI needs very many or lots of training data to get something right. So what is with rare things? Do we just have to do this manually in future, or is there a solution for that?
It's a great question. It was in fact a problem that we had when we were training these models to help us to sort of classify these hate crime tips based on what attribute of the victim they targeted. Was that we had about 5,000 tips, about 3,000 of which had been labeled by the person who submitted them. So we knew that this text about a particular hate crime corresponded to it being about race, for instance. And then the remaining 2,000 had no such label. We just had the text. And as you might expect, the distribution of those 3,000 tips that had labels, the 7 or 8 labels that we had were not evenly distributed. We had a lot more examples of, if I recall correctly, race-based hate incidents, religion-based hate incidents, and sexual orientation-based hate incidents than, say, whatever some of the other examples were, gender, for instance. And so I don't have a great answer. Our classifier does a lot better for those examples, those labels for which we had a lot of training data, and the ones for which we had very few, the classifier just doesn't know very much. It doesn't know what's a chance coincidence about the 100 or so gender-related tips. What's a coincidence and what's actual signal? What really is a sign that someone is talking about a gender-based hate incident? And so the solution there really is to get some more data, either by asking people for more tips or hoping that there are just fewer hate incidents there, so it's less of a problem, or relying on actual human beings with a lot more domain, understanding of the actual world.
Great, thanks. Jonas, you want to add something?
It's interesting that the two problems that you mentioned, so how to deal with smaller data sets and how to basically see why a model makes a certain prediction. These two problems have been also identified within the machine learning community as the most challenging problems, and everyone is trying to work on them because obviously it is not good to have models that will only work on gigantic amounts of data, and it's not good to have a model that can't tell you why it made a certain decision. And there are ways of making progress. For example, the word-to-vec thing, so newer developments are basically much more general, and you can basically use some word embeddings like these that are trained on a very, very large amount of text to get some background knowledge about basically language aspects, and then use these to improve on tasks for which you have only very small amounts of actual supervised data, and this already helps. And the question about explaining things, there are basically different techniques of somehow building diagnostic machinery that somehow tells us why a certain model made a prediction. And I think journalists should keep asking machine learning people, why are your models doing this? They can't tell you now, but if no one asks them, maybe they don't realize it's a very bad problem. Also, basically, lawyers also make them think in this direction, because if you want to build an AI, you have to know what the legal situation is. But this is one of the challenges that people are working on. And I think there will be progress, but I would actually be a bit careful, and I would basically never trust a system in a particular stage, because you can so easily trick things. So if you know what the machinery is doing, you can always trick it. So I think one has to always keep this critical distance, what I said at the end, and never trust fully, but double check.
But doesn't that exactly lead to the questions if we really should use the systems, for example, for comment moderation? Because if you say it's easily to trick, you can easily trick them, and people, of course, always find out, especially those trolls who want to trick them. So should we use them at all? Maybe, Varada, do you have an opinion or an idea of that?
Yeah, so like I said, I showed you that example of length. And then we saw that the performance of our models was like 93% accuracy. But then later when we investigated what's happening in the models, then we saw that, okay, most length is a very good predictor. And some of our models were basing their decisions solely on length. Right? So then if an adversary knows that, okay, if I write long comments, which are all garbage, but then the system will still say it's a constructive comment and put it at the top in the commenting section, right? So we don't want this to happen. So I think depending upon your use case, it's important to choose the model that suits you. So maybe the model might not have the highest accuracy, but it is not very sensitive to length, for example, in our case. And so we saw that some of the models were not very sensitive to length, for example. And then so depending upon the situation and your use case, then you can go for these other models. And so yeah, so I think these methods, they can still be useful in comment moderation, just that you have to be careful about your use case and what kind of model you are using.
I think that's really an interesting point and important that we think about this, that we always have the chance to find out what feature these models think, which is the most relevant feature. And as well, what Jonas said, ask researchers, we need this to know, help us, how can we find out what these models, how this decision came, how it decided and why it decided like this. I would like to open now to the audience. Are there any questions? We have microphones there. We'll bring them to you. Don't hesitate, so there's one question.
Test.
Yes.
Hi, thanks for your comments in the session. So this is, I guess, for Varada. I'm wondering about what you said. 93% accuracy. So I guess my concern, you're talking about weeding out the bad comments, which of course is important, but also making sure that we have the constructive ones, or the not bad ones, still there, the integrity of that comment system, if you see what I mean. So, so my first question, I have two related questions, is if you looked at that 7%, and other than lengths, saw patterns for what you didn't match up with, I guess, what the New York Times had said were appropriate comments. And my related question is, I can just imagine for my own commenting, something along the lines of a short comment that says, there's an op-ed, let's say, and I don't agree with much of it, but then there's something at the end that says, but maybe what's really happening is X, Y, Z. And then a comment says, yes, this is, the commenter missed the point. What's happening is X, Y, Z. Now, a lot of people might agree with that comment, what they say, and that's probably constructive, but it's brief, and it just repeats mostly what was in the text. So that's the kind of thing, it seems like, it's not just length, but there's something there that, because you're pointing to something, it's not the content per se, that would be hard to include with your algorithm, I guess.
Great question. So we experimented with different features, so our intuition was that maybe constructive comments have argumentation in them. So people are making points and then they are providing evidence for that to support that point. And so we incorporated some kind of argumentation features that so in computational linguistics we have we can create a discourse tree that kind of identifies whether there is argument presented in the text or not. And then there were also other readability features, for example. So what is the readability score of the comment? Or are they talking about specific points? So when we did annotation of these comments, we also asked people to mark down all these characteristics of constructiveness, whether it's opening a dialogue, for example, or whether they are talking about specific points, whether they are providing evidence. So in that analysis, we saw that dialogue had a very high score. So whenever people are encouraging a dialogue, then people mark that as constructive. And actually, another interesting thing we did was we were also interested in knowing whether when people agree with a comment, then maybe they think it's constructive. Right? So we also looked at that whenever, is it happening that when they are agreeing with the comment and then they say that, okay, I agree with this comment, so this is constructive. And actually we found out that was not the case in our data. Argumentation was the main feature, argumentation and opening dialogue. They were these were the features that were associated with constructiveness.
That sounds good. Thanks a lot, Varada. So here's another question.
When you're talking about comparing when you're analyzing comments, would you analyze that particular comment? Because it's usually contextual, right? If somebody else comments something and the response to that, for example, has irony or sarcasm, that makes it toxic, so to speak. How would it handle that situation?
Yeah, so that's a great question. So actually in our analysis, because of this problem, we only focused on top-level comments because we didn't know how to deal with these comments in thread. But so that's one thing we are interested in, is studying conversations. But in this analysis, we just focused on top-level comments.
Thank you. I guess the thing that terrifies me, I should say, the most is the math, and I wonder, is that something that reporters, communicators, whatever it might be, that want to benefit from these systems should worry about that very low-level math work that needs to be done, the really technical stuff? Or can we get into this at a very high level, which is basically buy in or use openly available systems that this data can be fed into?
Maybe that's something for you, Jeremy? Or
I would say cautiously, no. Don't worry about the math. I think that what's important is to get the right kind of metaphorical understanding that this is just a fancy way of fitting a curve to some data. It's kind of like linear regression. And once you understand that again, it's not a magical oracle of truth, but rather the math is finding a way to do a better job of quickly and accurately separating the two kinds of data, column A from column B, that is based on these training examples. Those are that line separation metaphor and the training data is the thing to focus on when you're wondering about the problems that may or may not arise from applying these models in high-stakes situations in our society.
But are you, just to follow up on that, are you finding that outlets are writing their own code, developing their own algorithms for this analysis, or are they going off the shelf and applying, some sort of readily available?
I think there's kind of a very broad spectrum from developing from scratch through to off the shelf, because even as you are going fairly low level, you're often still using what are called model architectures that have been developed by somebody else at other universities and applying them to whatever you're trying to do. If you're working with text data, whether it's comments or things folks are saying in Parliament, you're likely using one of, 2 or 3 general varieties of architecture, each of which has a bunch of different choices you can make. But whether you're doing this in academia or journalism, you're using one of those pre-developed kinds of architectures. And so whether implementing that yourself, you could do that. I'm not sure there'd be much benefit of it. And so I think that most of these sorts of application-oriented uses of these algorithms tend to be using stuff that's closer to the off-the-shelf side of the spectrum.
So since we are nearly at the end now, was there one more question? I don't think so. Great, perfect for our timing. I would like to ask one last question to all 3 of you. And this is, what do you think is the most fruitful use of AI for journalism in the next 5 years? Who wants to start? Jonas, you moved.
Yeah, so I think the way to go, and here the journalists should probably push the people who develop the machinery, is to kind of make the machinery more transparent. Basically, whatever decisions an AI is doing, it should be clearly kind of, people should be clearly seeing where it's based on. And this is something, if the collaboration between maybe journalists and other researchers on large amounts of data push the technicians to go that way, and that should happen in the next 5 years, this will be really, really good. So transparent use of these models.
And to really ask scientists to work on this for the whole of society. Yeah, thanks a lot. Varada, what's your take on that?
I guess comment moderation. And the other thing is that I have been thinking about is maybe linking organizations and people, so data about organizations and people from all different sources. I think that can be really useful for journalists.
Do you think about something like the network, that you can see who
right.
interacts with whom?
Yeah, so in computational linguistics, you can identify like people, organizations, and then you have so many different data resources, like from government, there is some kind of data, and then if you can link data for that particular entity in all different, from all different sources, then that can be really useful.
That's really a good point, because really parliaments produce tons of data, and I think many of them just nobody looks at them because it's just too much. But really there are stories in that, and I think the only way for us to find them, or one way for us to find them, is to use computers and machine learning to find what the stories are hidden in these documents. Jeremy, you are the last.
I think that's exactly it. That's where the promise is for the next 5 years for us as journalists. It's sort of a happy accident of our so computerized age that whether it's through leaks like the Panama Papers or the Snowden documents or just freedom of information laws, that journalists can now get their hands on millions of documents about important newsworthy stuff with relative ease. What's hard then is finding what you're looking for when you don't even know that you're looking for it in those millions of documents, when you know you won't have time to read all of them and really digest what's in them. And with some of these relatively simple artificial intelligence and natural language processing techniques, we can sort of superpower the way that we search through these documents. in a way that will let us more easily find the stuff that the public needs to know.
Thank you so much. It was a great discussion. Thanks for your interest. Thank you for coming and telling all these important things to us. Have a nice day, nice conference, and see you next time. Bye.